Welcome back. I hope you are doing great. In the previous section, we understood about the aggregations. As a part of this section, we'll understand the joins. If you are from a SQL background, if you have already worked on joins, then joins in Spark will be a cakewalk for you guys. Let us understand joins in detail. As I already indicated, we have done aggregations in our previous section. But how aggregation is different from the joins? If you recollect, aggregations we have done mostly on the single data sets. What do I mean by that? Single data sets here I mean data frame. So let us take an example here just to refresh your memories. So this is a data frame with 3 columns. One is employee ID, another one is employee name, another one is salary. We may have like some thousands of rows as a part of this data frame. If you remember, either we have found a min of this column, max of this column, or sum, or we have counted. We have done so many aggregations, and all of those aggregations are done on the single data frame, either on a single column, or if you remember, there is a covariance, correlation, all of them done on multiple columns. Okay, we have done aggregations on one data frame. Do you think all the data engineering tasks would have only one data frame? Not really. That is where our Spark has the ability to read from multiple sources. It may be CSV file, it may be JSON file, it may be text file, it may be any RDBMS databases. The Spark has a ability to read from multiple sources. It can be a semi-structured files, or it can be unstructured, or it can be structured databases. If you look at any organization for that matter, organizations tend to have data from multiple sources. It can be in a semi-structured Parquet format, it can be a structured RDBMS databases like MySQL, Oracle, PostgreSQL, etc., or unstructured files. That is why Spark has the ability to read from multiple sources. Now, we already understood Spark has the ability to read from multiple sources, and data engineering tasks tend to have a comparison between one data set with the another data set. Thanks to Spark, Spark has a ability to make that happen, comparison between a one data frame with the another data frame, because Spark understands that data engineering tasks or data analysis tasks tend to have a comparison or combining the different data sets. We have been thinking about a joins. What exactly is a join? What are joins? Join usually bring together two sets of data. Here we are talking about the data frames. One will be on the left, another will be on the right. What we do is we compare the value of the one or more keys of the left with the right, and we evaluate the result of a join expression which we have already given. That join expression determines whether the Spark should bring together the left data records with the right data records. That's what is join is. We'll understand how it works in the next lecture in a bit more detail. We do have different joins, like we have inner joins, we have outer joins, we have left outer join, we do have a right outer join, we have left semi joins, we have left anti joins, and we do have Cartesian product or cross joins. What we will do is, we will wrap up our lecture here and understand all these joins as a part of our upcoming videos. Thank you. You have a wonderful time.